So we are now moving on to another item, that is change of the bases of the logarithm. They may give you a base and you want to take it to another base. So these are the scenarios which we do on this. The first one is we have got log of b base a can be put in terms of log of b base c all over log of a base c, or log of b base a is the same as 1 out of log of a base c. Number 3 is log of b base a is the same as log of c base a times log of b base c. So somebody may ask you how is it coming? So I'm going to do for you one proof. I'll do the first two proofs, then the third one you can also try it by yourself. The proof, like for number 1, you can say let log of b base a equals x. From the other index form, this one is the same as what? B equals a to power x. A to power x. So when I reach here, I'm free to introduce taking log of base c on both sides. You can say taking, because you can see I'm having log at base c, that's why I'm using that one. Say taking log to base c on both sides. So one take log to base c after reaching here. This implies it becomes log of b base c equals log of a power x base c. From our term, this one is raised here. What do I remain with? I am going to remain with log of b to base c is the same as x, log of a to base c. So can we make x alone? How can I remain with x after reaching that step? Divide throughout by log of a to base c. So x alone equals log of b base c all over log of a to base c. But do we remember our x? Our x is already log of b to base a. So we are going to say log of b base a is the same as 1, is the same as log b base c all over log of a to base c as required. When I use that symbol, meaning as it is required. So we shall now move to proof for number 2. Proof for 2. Still I've said that log of log of b to base a is the same as 1 out of log of a to base b. You can see it was reading as log of b base a. Now it is saying 1 out of log of a to base. You can see the base is being what? Changed. You want to prove why is it like that. So we are going to use the same thing. You can say let log of b to base a equals x. So we use the index format. How do we get the index? This is the same as b equals a to power x. B equals a to power x. So what I'm going to do, I can see here now there is log to base b. Taking log to base b or introducing log to base b on both sides, can say taking log b on both sides. So want to be taking those logarithms on both sides. Then we see what will come out on this case. So after taking, what happens? We are substituting here. We are going to have log of b to base b, nice, equals log of a power x base b. This one is brought this side as we saw in the other rule number 3. So what am I meaning here? Log of b to base b, we say it is already 1, which is the same as x log of a to base b. So make x the subject, x to be alone. X becomes 1 out of log of a to base b. But do we remember our x? Our x is already log of b to base a. Then we say therefore log of b to base a is the same as 1 out of log of a base b as required. So whenever I tell you that there is change of this one, always follow what I've already given you here and do the more practice. And I beg that you do for me that proof for number 3. Try, and when you fail, please send it back to me. I'll help you on that. So we are going now to look at common logarithms. Common try to clean our whiteboard as we are going to go on with a new item. So we are going to look at common logarithm. Common logarithms. So I've got some logarithms or numbers which are common, which we need even with the moment you see it. There is no need of you to first alert us. We shall be aware that you're already talking about this one. So logarithm in which the base is 10 are termed as common logarithms. That's one I wanted to know it. Logarithms in which the base is 10 are termed as common logarithms. What are we meaning here? If they may give you a number that I have not put for you base, if they don't put for you the base, just know that these ones are what we call common logarithm. If they don't give you a base, know that it's base 10. So that's what has been there. So these logarithms help in easing decimal calculations accordingly. These logarithms help in easing decimals accurately. Take an example. If we have 10 power 2, this is the same as, when you say 10 power 2, it comes from what? When you say 10 power 2 is the same as what? 100. So, which is the same as when you see log of 100, just write as log of 10 power 2, then it comes just the answer is 2. Now, another one is 10 power 3. What comes into your mind? This is 1,000. This is the same as log of 1,000, which is the same as 3. So when you see log of 1,000, just put a 3. Where it came from? Because when you say log of 10 power 3, first do it here. When you say log of 10 power 3 base 10, 3 comes in 3, log of 10, 10. And we said log of a number related to a number is the same as 1. So, another one is 10 power negative 2. This is the same as 0.02, which is the same as log of 0.02, which is equal to 0.02. So those numbers are very, very common. The moment you see that one, no need of you to rush, just go there and calculate it. The more on that. So those are what we call common logarithms. And the logarithms are denoted by log or that one. All of them, they are the same. Or somebody can say log x, it means it's base 10. If I have to put here x, or log, or you don't put that one, you say or log base 10. All of them, they are the same. If they don't include this, if they don't put the base, just know that the base is already 10. The base is already 10. But if you don't do that, then automatically you will not have achieved what is required from you. So we are going to start now with serious examples on this, which I want everybody to follow up. Let me try to clean here. And we see what we're going to be applying them. There's applications of logarithms. We're going to look at applications of logarithms in details. So let's start with the first example. Example 1. They have said that given that log of 5 equals, log of 5 equals 0.69. 0.69. You can press on our calculator there. 89.70. Then I've said evaluate log of 8. Evaluate log of 8. They have already given you that log of 5 is given as 0.698970. And I've said evaluate log 8. You can see here, when they say log of 5, it means it's log of 5 to base 10. Even here the same, log of 8 to base 10. How best can you do this one? So they want you to use an inquisitant which is having a 5. That means whenever you're playing with log of 5 or 8, make sure that there is that 5 which is there. So let's try to look at the solution. So plus 8 is the same as, if somebody say 1,000 divided by 125. Can you first test that one? When you say 1,000 divided by 125, automatically you will come out with 8. So we'll go ahead. 8 is the same as 1,000 is the same as 10 to the power 3 out of 5 to the power 3. But I was given log. I also introduced log on both sides. I will say log of 8 equals log 10 power 3 out of 5 power 3. Then we apply our rules which we have already tried to look at. When we are dividing in logarithm, we do what? We subtract. So this is log 10 power 3 minus log 5 to power 3. So when the powers are up from still our rules, this one is brought aside. So this becomes 3 log of 10 minus 3 log of 5. So, and we say that log of a number related to a base is the same as 1. So what I've remained with, 3 minus 3 into, do we know log of 5? Log of 5 is already given. It's given as 0.698970. Then here you are free to multiply and come out with a clear C. We also can even multiply. This is the same as 3 minus. Can we press on our calculators? 3 times 0.69. So we are getting 2.096910. Then we apply the usual elementary of subtraction. What are you getting? We're getting 0.903090. Then you have already achieved the best on that. So when the numbers comes in that manner, I expect you to do